Pressure reduction to sea level, PRSL. Pressure reduction to sea level is a technique to adjust pressure values to the sea level. There are basically 6 variables we are looking at in this approach. They are temperature in Kelvin, change in elevation in meters, average pressure in Pascal, gravity, which is constant at 9.81 meter per second square, gas constant of 287 joules per kilogram Kelvin. And change in pressure in Pascal is what we are looking for at the end of our calculations. The equation we are using in this approach to find the change in pressure is given by the average pressure with a negative sign multiplied with gravity over the gas constant, temperature, and multiply the whole thing with the change in elevation. As we seen in the previous slide, we got a lot of variables with different kind of units. So for Pascal, for pressure, the gas constant, and gravity, we're going to change the units in relation to newtons, meters, and kilograms, and Kelvin. With these new balancing units, we can see how they cancel out in our equation, leaving us the change in pressure in Pascal. So, our calculations. In step 1, we have to convert all the data into appropriate units for our convenience. For example, degrees Celsius or Fahrenheit have to be in kelvins, millibars into pascals, and the elevation needs a negative sign because it describes the change in elevation from top down to the sea level. And then at step 2, we have to calculate the average pressure using our station data. For example, we are given a certain pressure values at the station and at the sea level. We have to add it up and divide it by 2, giving us 91,513 Pascal in our example in here. In our third step, we have to plug in all the values into our equation. In our example in here, we got temperature, elevation, and average pressure. Plug in everything, and we got 18,030.4 Pascal. And we see how the units cancel in here. Newtons canceled out, kilogram canceled out, Kelvin canceled out, meters canceled out, leaving us Pascal again. So then in step 4, we have to ask one question. If we add up delta P, the change in pressure, and the pressure at the station, does it equal to the sea level pressure? So in here, we do the add up, and we got 99,730.4 Pascal. This is not equal to what we use for our sea level. Not within the 100 Pascal or 1 millibar. In that case, if it's not within the range, we have to repeat step 2 to 4 until we hit on a value that lies within the range. However, in our subsequent calculations, we're not going to use the same sea level value. We're going to use the sum of delta P and the pressure at the station to substitute sea level. So we see in step 5 here, we repeat calculations, do the average pressure. We got 90,715.2 Pascal. We do the change in pressure calculations do the checking, and still it's not within 100 pascal of the substituted sea level value. So to repeat it again, in step 6, we calculate the average pressure, delta P, and do the checking. So now we got our values, the sum of the sea level pressure and the change in pressure equals to 99,578 pascal. This lies within the 100 pascal range of 99,591 pascal. So we've done a calculation, and this is our equivalent sea level pressure. And 178.18 millibar is the pressure correction. So we're done.